Hey, how's it going? So, I got a request on YouTube for section 1, chapter 11. One of the commenters said he was having trouble with this one, so I just decided I'll make a video. I'll just go through it and do it with you. This is just the first time I'm doing this one, so let's see how it goes. So, it's about keccak256 and typecasting. So, we want this function called generate random DNA to return a semi-random uint. Just ignore the semi part for now. But pretty much what this is saying, it's telling you what the keccak256 is, and what it is you put an input, right? So AAAAB, and then it creates this random string. But every time it's gonna be the same. So based off the ID, there's a random string. So for this, it's this one, and then for AAAC, it's this one, and that's pretty much what it does. So it kind of encrypts what you're putting into this crazy long hash. And yeah, right here it's saying that the return values are totally different despite only a one character change input. So like, yeah, we just changed a C, and over here we changed a B, and look, these are totally unrelated. And then this is just a disclaimer that you can ignore if you're a beginner. And then typecasting is fairly simple. I've seen it in other programming languages like C++ and Java, etc. And that's pretty much when you change the type of when you convert between data types. So there's a uint 8 and a uint 256 because that's the default, and then variable a, variable b. So if you wanted to make a new variable and you multiply a and b, these are not the same data type, so it's not going to work. So what you have to do is they have to be the same. A is a uint 8, b is a uint 256. So what we're doing right here is we're converting b into a uint 8 data type. So now this calculation will work, and the compiler will not throw an error because they are the same type, and they need to be the same type for it to work. Let's see what this says. A and B returns uint, but we're trying to set uint 8, which causes potential problems. So that's pretty much what I just said. So let's fill in the body of our generate random DNA function. Here's what it should do. The first line of code should take the keccak256 hash of ABI encode packed string to generate a pseudo random hexadecimal typecast as a uint. Finally, store the result in a uint called rand. All right, so that's an insane sentence. Don't let that scare you. What it wants, it's work backwards. I always like to work backwards. So store the result in a uint called rand. Uint rand equals. So that's done. No. Okay, typecast it as a uint. If you want to typecast, you do this. Uint. And whatever goes in here is what you are converting or you're typecasting. Now, we did this part. We did this part. Now, where are we? The first line of code should take the keccak256 hash of ABI encode packed str. So this is the format to do a keccak hash, and I'm just going to do it on another line to make it simpler. And whatever goes in here is what's going to be hashed. So this value of str goes in there, and then yeah, that's pretty much what we are setting the variable to. Now we want to put this guy. Let's put this guy in here because we are typecasting it. So yeah, it's a pretty crazy line of code, but what it is take a uint rand, set it equal to a typecasted uint of the hash of this string. And then let's see what number 2 is. We want our DNA to only be 16 digits long. Remember modulus. So the second line of code should return the above value mod DNA mod. Okay. Return rand sent for modulus DNA modulus. And if you don't understand that, go back and look at mods, but it's pretty much like a remainder function. And we want our DNA to only be 16 digits long. DNA mod right here is 10 times DNA digits. Okay. Yeah. If you don't understand this one, go look up modulus. It's really simple. But yeah, this lesson is more about typecasting and hashing. So that's what we did right here. And yeah, that's it. Thank you.